Hello and welcome to the Section 11.1 application walkthrough. In this section we started looking at radicals and we looked at simplifying radicals. And really what that means is sort of breaking down the square, what's under the square root into its most basic items and seeing what we can pull outside of that square root symbol. So if you remember, kind of the way I like to do it is using a tree diagram. I'm going to go ahead and look at number 1. I think it's a little bit tougher. So if I look at 112 and I divide it by 2, I know that it's 2 and 56. I'm going to keep dividing by 2 while I can. So 56 divided by 2 is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. So that's the most basic elements of the coefficient that we have here, and then we have some things to look at with the variables. But let's go ahead and simplify this. Who has an exit buddy? Remember the video Finding Nemo? They're getting off the Eastern Australian Current. You got to have your exit buddy. So I have two 2's that are going to come outside. Okay, 5 times 2 times 2. And then what's left is the 7. And then I'm going to leave my variables here for just a second. Okay, and look at what I have here. A to the 4th means a squared times a squared. C to the 4th means c squared times c squared. Okay, and you can continue doing this if you need to. A and A, C and C, C and C. Look for exit buddies, so I'll have 1A coming out, 2A's coming out, 2 C's coming out. So what we're going to be left with is 5 times 2 times 2 times A times A times C times C. And then what's left inside is just the 7B. So what I really want to do is take out as much as I can from the square root to leave as little inside the square root as I can. Really what I need to do now is to multiply all this stuff together. 5 times 2 is 10 times 2 is 20. So I'll have 20. 2 A's, A squared, 2 C's, C squared, square root 7B. So that's how you're going to be looking at doing those problems. Okay, number 2, again, it's similar to number 1. I would say it's a little bit easier, but that's just me saying that. That doesn't mean a whole lot. So it's still worth the time for you to look at it seriously and give it a shot. In the next section, it talks about perimeter and area of a square. So the perimeter of a square can be described in terms of the area by the formula P equals 4 times the square root of A. So I want you to find the perimeter of the following squares. So I'm just going to use my formula and plug in the area for the A. Okay. Well, the beauty here, and actually for both of these problems, is both areas are perfect squares. The square root of 225 is 15. So that means that the perimeter is 4 times 15, which is 60. Include your units to make sure that you get it right. Since the area was in meters squared, the perimeter is going to be in meters. Okay. Let's go ahead and look at the next set of problems. Okay, number 4 is just like number 3. But let's go ahead and look at this. So the time t in seconds it takes an object to free fall a distance d is given by the function t equals 1/4 the square root of d, assuming there is no air resistance, of course. So air resistance talking about the drag of the object, the force of the wind that pushes up to actually slow the object down. So how long would it take a 25-pound bowling ball to fall a distance of 64 feet? All right, it's a pretty heavy bowling ball, I'm just going to say that. But it doesn't really matter because all I'm worried about is time and distance. So that 25 pounds, that's one of those distractor numbers. You don't have to worry about how heavy the bowling ball is. Okay, we just know that it's going to fall 64 feet. So t equals 1/4 the square root of 64. Square root of 64 happens to be a perfect square, and that is 8. So 1/4 times 8. And 1/4 times 8 is 2 seconds. Okay. So what I want you to do from here is look at number 6. Okay, and number 6 is going to be really similar. In fact, scary-wise similar to number 5. Because if you look at it, we're following the same distance. Yeah, it's a 1-pound baseball this time, but remember I crossed out the weight of the object in this one, so you could cross out the weight here and look at how you would do that problem from there. Don't worry if you think your answer is wrong based on previous answers. All right, give you a hint, it's probably going to be similar to number 5 again. Okay, so what I want you to do is get those problems done. If you have any questions, feel free to ask, and good luck on the Mastery Challenge. We'll see you later.